Hello, my name's Erik Gauger. I'm a researcher in the Institute of Photonics and Quantum Sciences at Harvard University. I'm a theoretical physicist, and my research is concerned with quantum technologies. If you think about how a very small system behaves, if you take a piece of matter and you look at an ever smaller piece, at some point you end up, all you've got left is an atom. And then I guess my research is concerned with how atoms, or small numbers of atoms, behave. And they behave very differently from what we experience in our everyday world. For example, an atom could be in several places at the same time. It can sort of be here, and it can also be there. It's not either or, it's not here or there, and we just don't know which one, and there'd be nothing mysterious about that. It genuinely behaves as if it's doing both, and that's known as quantum superposition, or Schrödinger's cat. And another thing that's fascinating is, when you're talking about, in the quantum world, about quantum particles, which usually means going, as I said, to very small systems, we have what Einstein labeled a spooky action at the distance. Some measurement or something I'm doing with an atom over here might, without any time delay, affect the result I'm getting over there. And Einstein said that can't be true because there must be some spooky action at a distance, and that shouldn't be happening faster than the speed of light. But for all we know, it actually happens. And that's those are two things which exist in the quantum world. They're very counterintuitive. I think it's fair to say no one properly understands it. We understand the mass. What we're trying to do is to kind of tap into that as a resource and build technologies which exploit these phenomena. So that's, very broadly speaking, what my research is about. I guess a large motivation for my work is to explore how we can use these quantum principles to become better at, say, harvesting light or collecting sunlight and converting it into energy. And I'm taking some cues, I'm taking some inspiration from what happens in biology. In photosynthesis, a plant absorbs sunlight and then converts it into chemical energy. And it's a complicated, sort of long, complicated process. There's certain steps in that which work surprisingly remarkably well, much better than, I guess, in fact, we could design artificially in the lab. So there is some evidence that is to do with the fact that plants have learned to exploit quantum effects in an interesting way. So I'm hoping taking inspirations from that, I'm hoping to replicate that, maybe even go beyond that and design or work towards technologies which will enable us to generate energy cleanly. I think the answer is simply not at this point. What I'm hoping is that it will have an impact 20, 30 years down the line. But what I'm doing is sort of fairly fundamental research, which will hopefully establish some principles and enable us to think about designing new technologies which will have an impact in due course. It's very hard to guess which of these ideas will take off.
Wrestling an alligator was quite a frightening experience.